Alrighty, so for 6.3, we have double angle, power reducing, and half angle formulas. And this chapter is really just about using the formulas. And I'm going to allow you to have all the formulas. Okay, so here it's saying, example 1, use the double angle formulas. Okay, so again, they're all written in the textbook. Okay, so for this one, it says, given that sine theta is 2/3, for a theta in quadrant 2, find the exact function values. So for part A, they want you to find sine of 2 theta. So all you gotta do is plug in. Okay, so it's gonna be equal to 2 of sine of just theta times cosine of just theta. Okay, now the good thing is that they gave us sine of theta, right? It's 2/3. So all you have to do is find cosine theta. What are we gonna have to do? Right triangle once again. It's in the second quadrant. Draw your triangle. Label it like always. Okay, and we know SOHCAHTOA sine is opposite over hypotenuse, so this is going to be 2 for opposite, 3 for hypotenuse, and then you would have to find the adjacent by doing the Pythagorean theorem. Okay, another thing that it's actually telling us that we could use, because there's so many ways to solve the same exact thing, is that we can actually use a trig identity. Okay, so of course, if you did it this way, you're gonna get the same exact answer. So I just want to show you that if you want to do it this way, you're used to Pythagorean theorem. You want to just go ahead and square it up. So you're gonna do one of the legs squared, the other leg squared equals the hypotenuse squared, and then you're just gonna solve. Right? You can see that A is the square root of 5. Okay, and then based on that, you can get the cosine. So you might as well finish it this way. So cosine is adjacent over hypotenuse, so it's going to be the square root of 5/3. Okay, but remember that technically, let's make sure we label this correctly. Remember that in the second quadrant, cosine is always negative. Okay, so even though we did Pythagorean theorem and we got that A is the square root of 5, it is actually negative, going back to the fact that you always have to check your signs. So does the square root of 5 negative make sense for cosine in the second quadrant? Yes. And does 2 positive 2 make sense for the y value in the second quadrant? Yes, of course, all these y values are positive. Okay, so now that we have that, we're going to multiply it all out. And we get -4 square root of 5 all over 9. Okay, so that was one way you could do it. The other way you could do it is use the fact that if you have at least sine, you can find cosine, because we use the unit circle. And we know that the radius of a unit circle is 1. So here's our formula. So if I want to find cosine from sine, you can just manipulate the formula. So we're going to subtract sine squared. So we get cosine squared is 1 minus sine squared theta. And then square root both sides, so I can just get the cosine. Right? Now the cool thing is that I know sine theta. It was given to me in the very beginning. It's 2/3. It's going to be 2/3. Notice how when you do the math, and you make sure you have common denominators, and you multiply it correctly, so 2 times 2 is 4, 3 times 3 is 9. So this is 9/9 instead of 1, minus 4/9, which is the square root of 5 over the square root of 9, which is square root of 5/3. So notice how either way we're getting the same answer, but don't forget, it makes sense for cosine to be negative in the second quadrant. So either way, you do have to maintain the negative. Okay, so either way, you can use the formula, but you do need to figure out what is not given. You can either use the trig identities, or you can go back to the right triangle. Pythagorean theorem never will steer you wrong. In fact, I think that we actually solved it faster because you didn't have to manipulate the trig identity. But again, it depends on the instructions and it depends on the way that you prefer to do it. Okay, then it's asking us, can we do cosine of 2 theta? Well, that's a different formula. And you have options for this one. Usually these formulas are given to you in like SATs and stuff like that, because it is very useful. Okay, so now it's telling us to find cosine of 2 theta. Okay, so we're gonna go ahead and use, well, we could use any of them, but we're gonna go ahead and I mean, the book is using the first one from what I can see, but I think that I want to use the second one. Okay, so for the second one, all you gotta do is 1 minus 2 times sine squared theta. And remember that they gave us sine squared. They gave us, they gave us sine theta. They said that sine theta is 2 over 3. So we're gonna do 2 over 3 squared to get sine squared of theta. This is sine of theta. Okay, so 2 over 3 squared is 4 over 9 multiplied by a negative 2. Find common denominator, and you get 1 over 9. Right, 9 minus 8 over 9. Okay, so we got the answer. And then C says, can you find tangent of 2 theta? That is a different formula. All these formulas you could have. Tangent 2 theta is 2 tangent theta over 1 minus tangent squared theta. Okay, so now they're asking us, can you find tangent 2 theta? As you can see, we're going to need tangent, but the good thing is that we already found sine in part A. Remember that sine? We got that the sine of 2 theta is negative 4 over square root of 5. So we got this for sine of 2 theta. Right? We got 1 over 9 for cosine of 2 theta. So now for tangent 2 theta, we could use this formula, which makes you get the tangent of just theta, or we can use the fact that tangent 2 theta is going to be the same as sine 2 theta over cosine of 2 theta. These are all formulas. You want to take a snapshot, make sure you write them down. So we actually can just divide these. Okay, so keep, change, flip. And it'll give us the result that we need. And that's it. Okay, so that's that. You have more practice problems to do. Example number 2 is another identity problem, which I will do it in CASA as well. Okay. Now we need to use the power reducing formulas. Okay, so those are different formulas. I'm gonna try to not take the whole board for them. Okay, so these are the new formulas. These are the power reducing formulas. Okay, almost done here. Alright, I will also do this one in class. Then we have the half angle formulas. Okay, so I'll write that over here. Okay, again, you can snapshot these. This is the half angle formulas. Alright, remember plus or minus is based on the quadrant. And so this is going to help us if we want to find an angle that is not in the unit circle. We are going to be able to use one that we do have, divided by 2, and get the one that they're asking us for. Okay, so this is example number 4. Alright, the power reducing, you just plug in at this point. We already went over what cosine 2 theta is in the previous problem, and I will prove one identity for you guys in class. Okay, so let's just use the half angle formula as an example 4. So it's asking us, can you find out what the cosine of 157.5 degrees is? Well, we don't have that in the unit circle, but let's see if we were to multiply it by 2, if we do have that angle in the unit circle. 315 degrees, do we have that in the unit circle? Yes, we do. Remember right here, this is 270. I told you guys the trick, 30, add 30, 15, 15, 30. 30, 15, 15, 30. So here we're getting 30, 15, 15, 30. So we do have 315 in the unit circle. Okay. What is that? That is 7 pi over 4, or remember cosine is positive here and sine is negative here. So this is the quadrant. Okay, this is a quadrant and the coordinates. Okay, so now they want us, can you solve for cosine of theta? Yes, of course. So we're going to use this one right here. Well, obviously. Okay, so this is going to be the half angle formula. So it's going to be cosine of theta over 2, where theta is this, where theta is 315 degrees. Okay, so these are equivalent. Okay, so we're just going to use the formula. So is cosine going to be positive or negative in the 4th quadrant? Cosine is negative. Okay, so then we're going to get the square root of 1 plus the cosine of alpha, where alpha is 315 degrees, all divided by 2. Okay, so the cosine of 315 degrees is the square root of 2 over 2. So it's going to be 1 plus the square root of 2 over 2. And now we just have to do some algebra stuff. Okay, so, oh, they're nice to you. They let you use double radicals. Okay, that's good. So here, let's find a common denominator. Let's add it up. So we can get 2 plus the square root of 2 over 2 for the numerator, and then keep, change, flip. Okay, and this is gonna be all square rooted with the negative. Okay, so here the cool thing is we get 2 times 2 in the denominator, which is 4, and we get the square root of that, and we're gonna also get the square root of the top, which is just 2 plus the square root of 2, because this guy doesn't, the 1 doesn't do anything, right? So our final answer is gonna be the negative the square root of 2 plus the square root of another 2 all over, what's the square root of 4? 2. And so this is just, again, more algebra. Okay, it's asking you to verify an identity, and we've done those in class. Remember that if you were trying to prove an identity, you're going to start with the left-hand side. If you don't have anything that you feel like you can do, you can always multiply it by the conjugate per se. And then with that, you're going to be able to use a trig identity. You're going to be able to square root it. And then there comes a point that you just have to think about it. And you have to think about, okay, since I'm square rooting, remember I can get a positive or negative, but in this exact problem, is it going to be negative or positive? Okay, so if we have time, we'll do one of those, but that's pretty much it. So our last problem is just the half angle formulas. Okay, so the half angle formulas. Okay, so that's example number 6, and then we're done. Okay, example number 6, half angle formulas is saying sine of alpha is negative 4 over 5. Alpha is in between pi and 3 pi over 2, which means it's in the third quadrant. Find the exact values. Okay, great. So part A is saying, can you find sine of alpha over 2? Remember that the formula says, I erased it, but the formula is, for sine of alpha over 2, you just do plus or minus the square root of 1 minus cosine alpha over 2. Now, is sine in the third quadrant positive or negative? Remember, sine is y, so it's negative. So we're going to go ahead and use the negative. Okay, and then thankfully, looks like we're going to have to create our beautiful right triangle because they want us to use cosine, but we only have sine. Okay, this is why we did this in chapter 5. So if you label the triangle, we got opposite, adjacent, hypotenuse. Okay, so this is SOHCAHTOA, so it's opposite, negative 4, and hypotenuse is 5. You guys know how to do the Pythagorean theorem, so this is just going to be 3, okay, but negative 3 when we use it to solve it out, right? So obviously a real triangle is going to have positive units, but I'm labeling it with the negatives so that we make sure we have the right sign when we finish our problem. Okay, so cosine is negative in the third quadrant, and so is sine. So that's why these are both, the legs are both negative. Okay, so now we can go ahead and we can apply this formula, and it says to do the cosine of theta. Now cosine is adjacent over hypotenuse, so it's negative 3 over 5. Okay, so now just do the math. So now we're going to have 1, which I'll rewrite it as 5 over 5, plus, right, a minus, plus 3 over 5, all over 2. Forget the negative in the 1. This is just going to be 5 plus 3, which is 8, so it's 8 over 5 square root. 8 over 5 divided by 2, so keep, change, flip. So we get 8 over 10 with the square root. Now, of course, we can simplify that. So that's 4 over 5. So it's, you can split it, but I think that that's good enough. So negative square root here, let's see. And that's it. I mean, you could split it into the square root of 4 over the square root of 5, which is 2 over square root of 5. Okay, now one thing I do have to mention that I had to look at is that for here, normally we look at just the sine of the angle, and then based on the quadrant, we know what it is. So for example, sine of just alpha is in the third quadrant, which is negative. But this formula is actually sine of alpha over 2. So now we're actually dividing it by 2. So that is going to make the value smaller. So for example, if you have some, let's pick some degree between pi and 3 pi over 2. So let's, I don't know, you could pick 210 degrees, right? That's an angle in the third quadrant. If you divide it by 2 to use these half angle formulas, what is 210 divided by 2? That's 105 degrees. And where is 105 degrees? It's cosine of, it's actually in the second quadrant, right? Just hypothetically. Well, it'll be closer to here. Okay, so actually you have to think about a sine in the second quadrant when you're getting sine of alpha over 2 because it's a half angle formula. So the sine in the second quadrant is actually positive, right? It's the y value. So that's why this is actually all positive. Okay, so again, we'll be able to work over more of these. If you want more practice problems, the book has a bunch. Okay, keep it up. We will go ahead and do 6.4, 6.5 in class, and we will do some of the trig identities, and then we'll continue with chapter 7 on Thursday. Okay, take care, review, and you're doing great. I know it's a lot of work, but just practice, practice, practice. Draw your right triangles, Pythagorean theorem, your formulas, identities, manipulate, algebra, unit circle. It all comes together in this chapter. So make sure that you're reviewing and understanding what we're doing. Okay, so take care, and I will see you soon in class on Tuesday. Bye, students.